EACC Math Lesson number 24, Simplifying the Square Roots. Down here we have several square roots showing. Some of them are nice and easy to work with. The square root of 25 is 5. The square root of x to the 6th is x to the 3rd. The square root of 28, not so obvious. So today we're going to learn how to deal with those. Let's look over here at Mr. Atwater's math test. The square root of 9 is 3, and that's a true statement, false, or who cares? It's true. Okay, so looking at our first examples here, these are the basic, fairly easy ones. When this number inside here is what we call a perfect square, in other words, if I can square a number and get that for an answer, that's called a perfect square. That's also our radicand. Okay. And this outside here, we call that the radical sign. Okay, so when this number's a perfect square inside there, the answer is pretty easy. The square root of 9 is 3. If you have a variable inside the radical sign and the exponent is even, we can take the square root by simply taking half of it. So the square root of x to the 6th is x to the 3rd. Just divide the exponent by 2. That always works if the exponent's even. Alright, so let's look at some situations that are not perfect. Square root of 28. Well, 28's not a perfect square. So there are several methods or ways to find this or simplify this radical. What I always teach the kids is simply this. Look for the biggest perfect square factor. Okay, so we want to find the biggest or the largest perfect square factor. Okay, so let's think of some factors of 28. Well, I have 2 times 14, but neither one of those are perfect squares. And the other pair is 4 times 7. And 4 is a perfect square factor. So what we're going to do is we're going to rewrite 28 in a factored form of 4 times 7. Now, we're going to use this property over here. The property says if you have the square root of a product of 2 numbers, you can split that up into the square root of 1 times the square root of the second one. So now we're going to use that for this. We're going to rewrite this as the square root of 4 times the square root of 7. The square root of 4 is 2, and the square root of 7 doesn't simplify, so there's our final answer. Okay? We've simplified the radical. Okay? Alright, so here we have a variable whose exponent is not even. When it's not even, what we do is we rewrite it with the largest even exponent. So a to the 7th, I can rewrite that as a to the 6th times a to the 1st. Notice that the largest even exponent is always 1 less than the original one. So if this would have been a to the 9th here, we would have had a to the 8th inside. Okay, so now using my property, I know I can rewrite this as a to the 6th, the square root of a to the 6th times the square root of a. And again, since the exponent's even, I can take half of that for my answer. So the square root of a to the 6th is a to the 3rd, and under the radical I still have an a. So a to the 7th, or the square root of a to the 7th, simplifies to a cubed times the square root of a. Okay, sometimes you'll have a combination of numbers and variables. That's okay. Just take them in separate parts. So for 12, I'm going to rewrite 12 as 4 times 3 using 4 and 3 because 4 is the largest perfect square factor of 12. Y to the 9th, I'm going to rewrite that as y to the 8th times y to the 1st. Now I can use my property and take the square root of the ones I can take the square root of. The square root of 4 is 2, so it's going to come outside of the radical. The square root of y to the 8th is y to the 4th, so it comes outside the radical. And under the radical, I still have this 3 and a y to the 1st power. So that's the simplified version of the square root of 12y to the 9th. Eight z to the 5th. Well, again, I'm going to rewrite 8 as 4 times 2. Z to the 5th, I'm going to rewrite that as z to the 4th times z. Again, taking the square roots of what we can, the square root of 4 is 2, so it comes out of the radical. Square root of z to the 4th is z squared, and under the radical, I still have a 2 times z. So I've gotten this into a simplified, it's called simplified radical form. Okay, now, there's also equations that have radicals involved. And it's basically a three-step process. Your first step is to isolate the radical. In other words, get it on one side by itself. So isolate the radical. So in this problem, I'm going to subtract 10 from each side to get rid of that 10. So I have the square root of x equals 21 take away 10, which is 11. Your second step then is to undo the square root. Well, to undo that, you square each side. So I'm going to square root, or square the square root of x, and I'm going to square 11. Well, whenever you square a square root, your answer is always the radicand, that number or letter that's inside the radical sign. And 11 squared is 121. The third step. Now, because we're doing all this squaring and stuff, you got to check your answers, because sometimes you'll get answers that don't really work. Those are called extraneous solutions. So you go back to your original equation, and you ask yourself, when I plug in the value for x, I'm plugging in 121, the square root of that, plus 10, do I get the answer of 21? Well, the square root of 121 is 11, plus 10 is equal to 21, so it does work. You've got to check it, though, every time. Every once in a while, you'll get an extraneous solution. All right, so another equation involving a radical, a square root. So again, step one, isolate the radical. So I'm going to get rid of this negative 8 by adding an 8 to each side. So we've got the square root of x plus 1 is equal to 10. Next, we're going to square each side. When I square a square root, again, my answer is just the radicand. And 10 squared is 100. Subtract 1 from each side, so x is equal to 99. All right, now we need to check it. You go back to the original equation. Is the square root of 99 plus 1, take away 8, equal to 2? Well, 99 plus 1 is 100. The square root of 100 is 10. And 10 take away 8 is equal to 2. So again, our answer checks. It works. Okay, quick review. Again, sometimes underneath our radical sign, we'll have nice numbers that are perfect squares. And the square root of 16 in this case is 4. Or if it's a nice variable with an even exponent, so if we have the square root of x to the 12th, we simply take half of that exponent, so that's going to be x to the 6th divided by 2. Not so nice then is when the number, or our radicand, is not a perfect square. So again, what you do is you rewrite it with the largest perfect square factor. Well, factors of 18 are 3 and 6. Those are not perfect squares, so I won't use those. But we can use 2 and 9. So I'm going to rewrite 18 as 2 times 9. Now take the square root of all the perfect squares. Well, the square root of 9 is 3, so it comes out of the radical. And under the radical, I still have that 2. So this simplifies to 3 radical 2. Simplify the square root of x to the 11th. Well, again, we rewrite that with with the biggest even exponent, which is going to be x to the 10th times x to the first. The square root of x to the 10th is x to the 5th, so we can bring that out of the radical. And under the radical, I still have the x to the first power. Okay? All right. If I have a square root inside of an equation, again, first step, isolate the radical, get the radical by itself. So the square root of x minus 4 is equal to 4. I subtracted 1 from each side. Square each side of the equation to get rid of the radical. When you square a square root, you end up with the radicand for the answer. And 4 squared is 16. And then we simply add 4 to each side. So x is equal to 20. And the next step, always check your answers for these problems. So is the square root of 20 take away 4 plus 1 equal to 5? Well, 20 take away 4 is 16. The square root of 16 is 4. And 4 plus 1 is equal to 5. So again, it worked. Okay. Well, you've got a set of problems in front of you. Please work through those. If you have questions, let me know. And look what we have down here. The square root of negative 1. Well, that's I. 2 cubed is 8. This notation here is how we write the sum. And the last word, or the last figure is pi. So I ate some pie, and it was delicious. See you later. Bye.